Hi everyone, I'm Kristin Speck and I'm a chemical engineer at Clorox, and I thank you for letting me come into your class today and talk with you a little bit about what a chemical engineer does. So I'm going to start with explaining what a chemical engineer does and talk about all the different things you can do as a chemical engineer, and then we'll talk a little bit about how I got to becoming a chemical engineer. So what things did I do in high school, what things did I do in college that got me there. So first, let's talk about all the cool things you can do as a chemical engineer. I brought some examples here with me. So I said I work for Clorox. Here's one of the products that Clorox makes. It's a GreenWorks bathroom cleaner. And the things a chemical engineer would do would really be to figure out what goes into this product. So what chemicals do we need to put in that are going to make you able to clean up bathroom grime or mess, and how are we going to make that? How are you going to mix it? How are you going to make sure that things stay together and they don't separate? If you think about if you've ever mixed oil and water together, and you shake it up and then you stop and then it just separates out, how do you make sure that doesn't happen as you mix these chemicals together? They might have different thicknesses, they might have different scents. How do you make sure you don't create a really nasty smelling bathroom cleaner and instead create one that smells really good that you can put a flower on the label? So those are the kind of things a chemical engineer thinks about. Some other products, I brought a Brita water bottle. Brita is also a Clorox product. Engineers are designing what this bottle is going to look like, how the cap's going to work, how you're going to pull it. The inside, this is the filter of the Brita, and the chemical engineer is deciding what do we need to put in this filter, what kind of carbon, what other things need to be with the carbon, how do we make sure that the water you get out when you suck it out of here is going to have different particulates like chlorine and lead and stuff taken out. So they do the testing for that. They talk to consumers. Consumers being, for this is a little kid bottle. They'll actually bring in little kids and have them try it out. How does this work? How are you able to get the water out? Is this lid really hard or easy for a little kid to be able to pull on? So all those kind of things a chemical engineer would do. This is not a Clorox product, but I thought this was kind of a fun one. Play-Doh. I think everyone's probably heard of Play-Doh. How do you make this? How do you make sure that it doesn't stick to your fingers? How do you make sure it stays moist in here and doesn't harden up when it's in this container? Those are something a chemical engineer would do. They would mix these chemicals together. They would do tests in the lab to try to figure out how you get this consistency. What about the dye? How do you make sure it's green? How do you make sure all of it stays green and you don't just have patches of green in there? Those are tests and things a chemical engineer would do to make that. What else do I have here? Hand soap. This is antibacterial gentle foaming hand soap. This is not a Clorox product, but somehow they have to put something in that makes this antibacterial. So there's special chemicals, and you can read on the back what the active ingredient is. Someone had to figure out that active ingredient would make it antibacterial. Someone had to figure out, how do you get that into here? How do you make sure it stays mixed in so that every time I pump, I get a little bit of that active ingredient so that every time I get that antibacterial. If you didn't make sure it was well mixed inside of there, you might get, from your first 2 pumps, you would get that antibacterial, and then the rest of it would just be regular soap. So how do you make sure that ingredient is well mixed? A chemical engineer is out in labs and pilot plants testing that by mixing it in giant tanks, figuring out all the different ways to mix it. How fast are you going to mix it? What is the tank going to look like? A lot of different things go into that, and those are the kind of things a chemical engineer would do. This is one of my favorite and a great category for a lot of women choose to go into: makeup. Personal products. This is Burt's Bees, lipstick. These are all things a chemical engineer is a part of. How do you get this color? How do you get the shimmer you want from it? How do you make sure that it stays solid and it doesn't just melt when it sits at room temperature? You've got to do a lot of testing to make sure that happens. For Burt's Bees, how are you mixing this? How are you making sure it's solid here? And why is it not just running out when it's at room temperature? Foods is a huge category. So I brought a couple Clorox products that most people don't know are Clorox products, but Hidden Valley Ranch, KC Masterpiece Barbecue Sauce. These are owned by the Clorox company. They are not made in the same plants that you would make bleach or any of our cleaners. They have whole separate plants, but they are owned by the company. Foods is a huge place for chemical engineers. And I know when you think of chemicals, you think about chemistry class and beakers with things bubbling up, and those are the chemicals you think of. But foods are chemicals too, and in fact there's a whole major out there called food chemistry that people get. And food chemists and chemical engineers both work on making food products. And so for several years in my career, I worked in Hidden Valley Ranch and KC Masterpiece and made food products. And so some of the challenges as a chemical engineer would be they want to add something to the ranch. They want to make original ranch with carrots. They actually want to see the chunks of carrots in there. And so if you think, okay, well, that could be good. It could be a healthy thing. You know, people want to see extra vegetables in their ranch. How do you make sure the carrots don't just sit at the bottom? They're kind of heavy. How do you make sure they're well mixed and they stay mixed in the whole thing? How large a carrot can you have? If you think about it, a plant, they're going to make these in large tanks and they're going to send them through pipes to a place where they can actually stick it into the bottle. And then they're going to fill these bottles. If you have chunks of carrots, how do you make sure that they doesn't get stuck in the line as it goes through to get to the end? And so there's all sorts of challenges that a chemical engineer deals with, and that's the reason for the college classes. They teach you things like fluid dynamics, which is how a fluid goes through a pipe, how fluid acts in a tank. And a fluid could be hand soap, a fluid could be a very thick ranch dressing, it could be a bathroom cleaner, it could even be Play-Doh. That's a pretty thick fluid, but it could be. So there's just a ton of different things that go into the products, and I would challenge you to look at anything, probably just there on your desks even, and you might think about a way that a chemical engineer touches it. On my iPhone here, not a ton that a chemical engineer does here, but electrical engineers do most of this. There are likely some very small components in here that could have a bit of liquid in it, which a chemical engineer could have a part of. But engineering is huge in making all of our fun gadgets we have today. The last one, now I know no one knows what this is because you're all under 21. Maybe your teacher, Mrs. Venuto, can let you know, but this is a bottle of beer. Beer is huge for chemical engineers. Lots of chemical engineers work in the alcohol industry. I have a great friend who works at Beam, which makes Jack Beam and a whole bunch of different liquor products, and he is looking at, again, their chemicals that make these products up. And so how are you going to mix them together? How are you going to let them age and sit for the right amount of time? If you think about the wine industry here in California, it's a huge industry. Lots of chemical engineers involved in wine. And what kind of barrels do you need to use? There's a lot of aging involved in wine. How long do you age it for? How large are the barrels? So a lot of things as you pump these liquids through to be able to fill it into the bottle. How do you make sure you don't get too much foam? Beer is actually foamy. I'm sure no one knows that. But as you pour it in, it can be foamy. How do you make sure when you mix it in the tank and you're making up big amounts of beer that you're not getting foam and it's all just foaming out of your tank? So there's a lot of fun things. I didn't grab any drugs, but think about Tylenol, Advil, all the drugs and medicines that we take. Chemical engineers are a part of those. And how you create those. If you think most of those are liquid, but even if they're solids, they're solid chemicals that make those up, and a chemical engineer is part of that. One of my favorite jobs that I had at Clorox was on Clorox disinfecting wipes, and I actually worked on the package, which isn't a typical route for a chemical engineer, but one of the great parts about a chemical engineering degree is the various things you can do with it. And so there are the typical jobs with chemicals that you would think of. There's the little less typical, but still chemicals, like the beer and the barbecue sauce. But then there's things like chemical engineers do get into electronics, and they might be working on the iPhone or the iPad. I promise there's chemical engineers who work at Apple. And then, like me, there's chemical engineers who might get more into the packaging side. And so one of the big projects, and probably my favorite project at Clorox, was I designed this lid on our Clorox wipes. And it's still the lid that they use today. And it was a project about 8 years ago. And before this, we had a really bad lid. And the consumers, or the people who bought this product, they hated it. And they called us all the time, the little 1-800 number in the back. And we do listen to those. And they called and they complained about it. And there were several complaints. The first was their wipes would dry out. So we didn't have a really good seal between the lid and the canister. They also complained because they didn't have a good opening, and there was this tiny little hole, and they had to find the wipe, and they had to stick it through the hole, and they'd complain, my finger gets stuck in the hole. And so we listened to all these complaints, and we started working with different suppliers. We actually work with suppliers who make this for us, and we started working with them on different designs. And so it was a partnership, which means it took a lot of communication on my part, a lot of just ability to work with others to be able to do this. And so we jointly designed it, and there are a lot of things that you wouldn't think about that were designed into it. A couple of examples. When I close this, I don't know if you can hear it on the video, but there's a click. This click was really important. You don't need this click in order to be able to shut this well. But as a consumer, as a person who's using this, you feel a lot more secure that the product inside is actually closed when you hear a click. So we made sure that there was a click, even though we didn't really actually need it. The other thing, how you use this, if you've never used it before, is you put your fingers through when it's on here, you grab a wipe, and you pull that wipe through. And so we had to figure out just how well do you clip these in, because they need to be able to be unclipped as you put your hand through to grab the wipe, but as you pull the wipe through, they also need to click. So there was a ton of design that went into just the right amount of force to make these little guys click into place. And so we had a lot of samples that clicked too easily and some that clicked too hard. And we tested and tested until we got just the right clickage with it. The other piece that's pretty interesting is the seal around here. And so we have a lot of different places on the closure that specifically matches up with the canister. There's actually 4 unique places where it lines up to mate against each other and to seal it, to keep it wet inside. And the cool thing about that was I actually got a patent for that. So I do have a patent for a United States patent, which means I created and own the design for that. If another competitor, like a Lysol, wanted to use that design for how their closure went onto their canister, they wouldn't be allowed to, because it's owned by me and the Clorox company. So some of the questions, people were asked about the dangers of working with chemicals. And, you know, definitely there are dangers. I don't work with the most dangerous of chemicals with the products that Clorox makes, so it's not like, say, when you're in some really specialty chemicals that can be very dangerous. However, there are some chemicals, and we do make bleach, which has chlorine, which definitely can be dangerous. And so there's a lot of safety that goes into what we do and what we make at Clorox. And so there's equipment you have to wear. When I worked in foods, really from the safety of the product we were making, we had to wear hairnets when we made it, beard nets if you were a man with a beard. Gloves, we had lab coats, so there are specialty things that we wear. Someone asked if I'd ever been in a chemical accident. I have not, but I will say my brother has been. My brother's a chemical engineer as well, and he worked in the pharmaceutical industry for a long time. And he actually blew up a side of a building working with some of the chemicals. He was fine. I think he had some light burns, but he was fine. But the plant wall was not. He did kind of blow it up and made the news. So again, nothing he did wrong, just a mixture of some chemicals, and so you do have to be really careful, and it did cause an explosion. I was asked what the most exciting part of my job is. For me, it's really the variety, and that's one thing that I think is great about being a chemical engineer, but also in what I do working at Clorox. There's certainly technical aspects, but there's a lot of things beyond just the technical pieces and going into the lab. And so there's If you think about the product making this, there was the times I had to work with the supplier who was making it, so there was a lot of sitting in meetings and communication back and forth. There was a lot of work with consumers, which is really fun. And you know, we actually got consumers to sit down and test this out. As you pull through, as you pull it, how does this work? And we'd ask questions. I was actually trained as a interviewer, professional interviewer with consumers, so I was allowed to sit down with them and ask them the questions and really test it out. There's working with marketing around design features. So there's little squigglies on here, and there's these little grooves at the top, and how are we going to do these, and what do we want it to look like? And so we worked closely with the marketing department around what the design was going to be. I had business trips where I would go out to the plant to see how does this run. How does it work when it's actually placed onto the canister? Does it run through the line as it gets there? So just a ton of variety. You're not just stuck every day going to lab. That would be the worst job in the world for me. But you get to do a lot of different things, and that's probably my favorite thing about it. The coolest thing I ever did, probably this would be my coolest thing, would the lid was something I was real excited about. Someone else asked about if the job is stressful. You know, I think any job can be stressful, and being a chemical engineer certainly has its fair share, and I think you know, it's really what you make of it, and to be perfectly honest, I think it's just how well you're able to handle stress in the thick of things. But yes, there are times when there's a lot of things going on and your job can feel stressful, but I wouldn't say it's any more stressful than necessarily any other job. So that's a little bit about what a chemical engineer does, and kind of some of what I've done at Clorox in my time there. My current product I'm working on is actually Burt's Bees. And working on some integration of some of their products with some of the things that Clorox does. You know, the last thing I'll say about chemical engineering in general, and there were some questions around this and people weren't even sure in some of the questions that they were supposed to be asking this, but is the money. So chemical engineering is a very well-paid profession. So if it's something you're interested in, it's something that you can get through college in, it's a great career. Because it's a great way to be able to support yourself and your family. So I looked up some statistics for you, just Googled it, and on the National Association of Colleges and Employers, it's the #1 career for the highest average salary, and in 2011 that was around $67,000. On Forbes.com it was the #2 career for undergraduates. But the #1 career was petroleum engineering, and frankly a chemical engineer can do anything a petroleum engineer can do. So you could count that as #1 as well. So okay, so now I want to talk about how I got into chemical engineering. So what things did I do in high school and college that made me ultimately become a chemical engineer and go to work for Clorox? So I'll start in high school. I always excelled at math. Math was definitely my favorite subject. It was the thing I was most interested in. I did good in chemistry and in the sciences, but I didn't necessarily love it like I loved math. And so as I thought about what I wanted to do after high school, I would have loved to have had the opportunities you're having as far as hearing about different careers. I didn't really have that, and so I mostly talked to my dad and my older brother, who was at the time at A&M studying to be a chemical engineer, and they said, you like math and science, you should be a chemical engineer. And I didn't get a whole lot more other than that. I didn't get any exciting talks about barbecue sauce. But you know, I was always hesitant because when they would say that, I'd say, well, I love math, I don't know that I love science so much. And they said, oh, but you're so good at science, and you get good grades in science, but I didn't necessarily love it. And I will say, from a career standpoint, that's probably limited me to some degree because there aren't a whole lot of areas, there are some areas of chemical engineering that would not interest me at all because they're so heavy into the chemistry and the science, and I'm definitely more interested on the math part. But the great thing about chemical engineering is you can be in so many different fields, and so you can look for jobs that aren't as chemistry or science focused and are maybe more math focused. And so that's something that I kind of looked for as I went through my time in college. So, like I said, I liked math. I did take a couple AP classes when I was in high school. However, I did not get any AP credit to go into college. So I started college with 0 credit and basically just started from scratch, and that was fine. I did great in college, and so you know, if you have opportunity to have an AP class, that's great, and have AP credit. If you don't, that's fine too. I went to a great school and was able to land a great job, and I didn't have AP credit, so it's really not a big deal. I did go in basically, and I chose chemical engineering because my dad and brother kept saying, you should be a chemical engineer, thinking when I get there I'll probably switch to something else, or once I kind of figure out what I'm doing. Obviously I ended up staying, but that was at least the little I knew going into it. As far as for me, I went to college at Georgia Tech, and I did go to high school in the Dallas area, in Flower Mound. And just for me, I really wanted to leave the area. I was interested in going out of state, and Georgia Tech had a great engineering school. It's always very well ranked from an engineering perspective. Engineering, though, is at most colleges. So whether you leave the state, whether you stay right there in the Dallas area, you can get a great engineering degree at a variety of places. But for me, it wasn't for the good school, but a lot of it was just to leave town. I just needed that experience for myself. Once I got to college, there are a lot of chemistry and math classes to become a chemical engineer. You do have to take a few English, like one history class. Basically, they have a couple mandatory humanities, and then you're really pounded into the math and science. So if you don't like math and science, this is definitely not the career for you. Or if you're not at least a little interested in both of them. I will say, you know, my chemistry classes were definitely the ones I struggled with more than, say, the math classes. You know, the math classes were much easier for me, a lot less studying, a lot more studying when it got to organic chemistry and physical chemistry. I think just because I didn't have the passion for it as much, and I just didn't have as much natural ability for it. Chemical engineering is a hard degree. You don't get to make that much money out of college for getting an easy degree. That's one of the reasons it's so well paid, is because it is a hard degree. So I did have to study a lot. My friends tended to be other engineers, and they were studying a lot as well. And so so that was okay, and that was something I knew that I wanted to do. But it is something that you have to be ready for, you know, a lot of commitment to be able to do it. One of the good things about it is you typically don't need to get more than just a bachelor's degree. So you can go off to college, and in 4 to 5 years you can get a bachelor's degree, and you can go off and you can get great jobs. And so the statistics I said before around starting salaries of around $66,000, $67,000, that's for bachelor's degrees of chemical engineering. Now you certainly can go on and get a master's, which takes another about 2 years, usually 1 to 2 years. Or you can go on and get a PhD, and a PhD takes usually about 5 years. I know at Clorox, we only look for bachelor's and master's degrees, and we don't really care whether you got a bachelor's or master's. Now, a lot of other industries are really looking for master's degrees these days. My husband is a chemical engineer, and he works in the pharmaceutical industry. And he's hopped jobs a bunch of different times. He's worked for smaller startup companies. And as he's looked at other jobs, a lot of them have wanted a master's degree. So he has found at times it has been limiting for him to only have a bachelor's degree. Now, I've been at Clorox since I graduated, so and Clorox loves the bachelor's degree, so it's always been fine for me. A lot of people also graduate with their bachelor's degree in chemical engineering, and they work for a few years, and then they go back and get an MBA, which is a Master's of Business. And that really helps them to have both the technical degree, but then the business side, and understand, you know, some of the things around finance and how do you manage people well, and all those kind of things. So, so that's something that I see a fair number of engineers do as well. So there was questions around how long I was in college. So like I said, I have a bachelor's degree. People do go through Georgia Tech and get a bachelor's degree in 4 years. I took 5 years because I worked a lot throughout that time, and I highly, highly recommend that as an engineer, or really any profession, that you get internships when you're in college. It is the best thing you can do for yourself to be able to find a full-time job afterwards. And I say that now as a recruiter for Clorox. I have gone back to Georgia Tech every year since I graduated. I think it's been 12 years. Looking for chemical engineers, interviewing them for Clorox, making the decision on whether they would get a job offer or not. And the number one thing I look for is previous job experience. It's not GPA, it's previous job experience. Where have they worked? What have they already seen that they might be able to come in and start at Clorox and know how it works to be an engineer. So it's a huge thing, and then the other huge benefit is you make a pretty good pay, which helps because it's hard going to college. It's expensive, and you're pretty broke while you go to college. So typical chemical engineers in an internship or a co-op are going to make anywhere from $20 to $30 an hour, maybe even higher depending on the industry. So it's a pretty well-paid job for someone who potentially only has a year worth of college experience. So for me, I worked a total of, we were on quarters at Georgia Tech, so there's 4 quarters make up a year, and I worked a total of 5 quarters. So I would go to school a quarter, I would work a quarter, go to school a quarter, work a quarter. And it was a great time for me to just get a feel for what does a chemical engineer do. I worked in a manufacturing plant that made photographic paper. You probably don't know what photographic paper is because you use your digital cameras and your iPhones to take pictures. But back in the days when Mrs. Venuto and I went to school, cameras had film in it, and you would take the film to the store and they would give you a packet of pictures on paper, and that paper was made by the plant that I co-opted at. And so there's a lot of science that goes into making that paper. There's chemicals that are coated onto the paper so that you can print your picture onto it. And a lot of the process was done in the dark. If you think about, if you've heard about pictures, and they have dark rooms. And so this paper had to be specially made in the dark room. And there were actually people who worked every day in the dark making this paper. And so as an intern, I worked on understanding what are the chemicals going on there. Do we want to change the formula? How can we optimize the formula and make sure that we're using the best chemicals and we're doing it in the cheapest way possible for the company? So I did that for 4 different quarters, and it was a great experience, but it also told me that I didn't really want to work in a manufacturing plant. Every day you went in and every day we made photographic paper, and I really wanted a lot more variety in my job. And so for my last internship, I went to General Mills, and General Mills makes a lot of food products and a lot of cereals. And that summer I worked on Cookie Crisp cereal. So you know the cereal that's a bunch of cookies that you always try to get your parents to buy, but they usually don't because it's got a lot of sugar. So my project was, how do you make the chocolate chips on the Cookie Crisp cereal better? How do you make them more chocolatey, look bigger? So as a kid, they look like these great big chocolates, and I really want to eat this. And so I spent time formulating with different chocolates, which you get to sample, which is awesome. So which one's going to taste the best? Which one's going to stick to the cookie well? How do we make sure it doesn't just blob on and then spread, and so it's just one big brown mess versus looking like chips on the cookie? How do you make sure it actually sticks to the cookie when you're making it? Do you want a big chocolate chip where you just have like 2 on the cookie, or do you want to have like 10 on the cookie? So all of those things are challenges I had to face during my summer internship. And that was the job that I really enjoyed, that made me say, hey, I want to work in the industry that's making all these kind of consumer products. And it helped me ultimately choose to come work at Clorox. I also like just the variety that you could work on Cookie Crisp cereal for a year, and then the next year you might work on fruit snacks, and then the next year you might work on a different product. So you got a lot more variety in your job. So it did take me 5 years to finish college because of the working, but again, it was when I graduated, because I had so much work experience and varied at 2 different companies, I had numerous offers, and so I really was able to choose where I wanted to go work, and that's a great thing to be able to do. And I did have a good GPA, so that certainly helped, but the key was my work experience. And so when I went into interviews, I had something to talk about. When they asked me technical questions, I was able to answer them because I had been in technical things, not just in a class reading a book. I had been on plant floors and seen these things and was able to talk about it. And that's what really allowed me then to be able to have a lot of different job offers and a lot of opportunities after I graduated. I did ultimately choose Clorox for a couple reasons. I liked the company, I liked the diversity of products they made, but I also liked that it was California. When I interned at General Mills, loved General Mills, it's a great company. However, they're in Minnesota, and it's really cold in Minnesota, and the internship I had was in the summer, and they're beautiful summers. But the rest of the year I wasn't quite sure I could handle. So a lot of why I chose Clorox was because of the location. And I think that that's an important choice, you know, as you're looking at a job. It's not just what you're going to do every day at work, but it's also where you have to live. Is this a place that you want to be? Is this a place where you want to raise a family? So, you know, California has been a great adventure for us. It is very different. It's very different than Texas, and it's very different than Atlanta, Georgia, where I went to college. So it definitely took some adjustment, but now I think Texas is very different because I'm so used to living in California. So let's see, I'm looking down my list of questions. You know, people asked about the importance of networking. Very important, I think, to network. It's a hard thing to do at times because it sometimes isn't what's part of your personality, and especially the typical engineering type tends to be a quieter, more introverted person, and so the idea of going out and trying to network and meet all these people, it can be difficult. And so sometimes it's almost a personality barrier you have to get over. I wouldn't say I did a lot of networking in college. You know, what I did was I took advantage of what my college offered. We had a great career services group at Georgia Tech, and this is a standard office at most, if not all, colleges and universities that help their students find jobs. And so I used them to interview with companies, and all the companies I interviewed with came onto my campus, and they were looking for Georgia Tech engineers. So that was obviously made it easier. But whether they're coming to your campus or whatever you're doing, the best thing is to use the services that your college or university would offer, just like you're using the services your high school offers. You're taking this class with Mrs. Venuto, you are listening to what I have to say, and you're thinking about what you want to do post-high school. Those same things are offered at college, and so I would definitely encourage you to seek those out. Even in your first year, you want to find an internship? Figure out, do I have a career services group? Go talk to them. How can you help me find an internship? What do I do to find an internship? Don't feel like you have to go find it on your own. My co-op jobs and internships were found through the career services group at Georgia Tech. They helped me get these jobs at the companies I found. So it wasn't that I was a great networker, it's just that I knew where to go to get help. The other thing I would encourage you when you do get to college is to look for opportunities to be mentored. You know, as you start off and you're a freshman, look for a junior or senior who is in the major you're looking at and talk to them about what you should do. What order should you take your classes? You know, there'll be professors that you can go talk to, but even better than that at times can be an actual student who's gone through it. And they might be able to tell you, you know, you should really take this class before you take this other class. And so I would encourage you to find those people, and then as you get older, to try to find people out in industry that can mentor you. And a lot of colleges provide that. I know now at Georgia Tech, they ask alumni to sign up to be a mentor to someone who is a student at the school. And you can, you know, talk with them and help them in what they want to, how they want to look for a job and what things they should be doing now to help them ultimately be able to find a job. As you start in your career, I would again encourage you to mentor and look for someone who's been in the career for a number of years and can help you and coach you. I mentor a lot of young people who come into Clorox who are a year or two out of college, and I help them with what choices should they be making with their career to move up. And so that's something that's really important to me to make sure to give back. I also have a mentor who's higher up than me who helps me in navigating my place in my career and where I should move up. So I think it's important to look for those. It's also important as you get to certain places to look back and mentor others. So maybe that means as you get to college and you're successful there, you look back to high school and say, hey, how can I mentor some juniors or seniors in helping them and how to go to college? There are some questions around, you know, chemical engineering and how is it different than other engineerings. There's a lot of base classes that all engineering degrees take. The main three engineerings are really chemical, mechanical, and electrical. For chemical, they're really dealing with the things inside the bottles, the liquids, the solids, the actual chemicals, whether it's a food chemical or whatever kind of chemical it is. Mechanical tends to be really more things that move. So, you know, cars are the typical things you think about, but even in our manufacturing plants, when we have a tank and you have a pipe that takes it to another part of the line, there's mechanics around how you shut down a valve and how you open it to let the water flow through. All those things are mechanical. So you have mechanical engineers who have helped design it and who are there to maintain it and make sure it continues to work. And then electrical engineers are really working on the electrical parts of it. How are all the things wired? How do we get electrical signals to different parts? Electrical engineers involved in all the gadgets we love today. So that helps with it. You know, they're between chemical and mechanical, there's a lot of people I know who have mechanical engineering degrees are now doing a more typical chemical engineering job and vice versa. So both of them are very good degrees that you can get, and you can do a ton of things. And as you get experiences, you can go in areas that, you know, a chemical engineer wouldn't typically do, kind of like the packaging role I did. But it's such a versatile degree, and you've got so many skills that you're able to kind of do that as well. Let's see, someone asked if I ever thought that I wasn't smart enough to do this, and the answer is absolutely yes. I doubted a lot through college. It was a hard degree, and I think even as a woman getting the degree, there's a lot more men in engineering. It's a little better now, but it's still more heavily male than female, and then it's a little overwhelming at times. Like, can I really do this? And I had that, you know, in my career at the beginning as well. Like, am I really ready to do this? Can I just take a product? Can I make a lid? Do they really want to give me this project? Do they think I'm able to handle that? I think, you know, the main thing is make sure you surround yourself with people who can help you to see the value that you do bring and kind of help build you up. But you're not alone. There are definitely times when I doubted myself and whether I could get the degree, do the job, but you can. You know, I think if you really put your mind to it, you can. Let's see if there were other questions. I think that's it. It's been great. I appreciate you listening. If you have other questions, I'm happy to answer them. Since I'm not there in person and can't just answer them, you're welcome to ask Mrs. Venuto, and I'm happy to answer via email or even do another video if there's that many questions. And I wish you the best of luck in all the different career choices you have and different college choices as well. Thank you.